Want to save lots of gigabyte during a logging campaign with ease? Then this one is for you. In this video, we will highlight live compression of camera data. To make this as close to reality as possible, my colleague Fabian is role-playing as one of our typical customers.
Hi Björn, nice to see you.
Hi Fabian, nice to meet you again.
So you know that we're running this data logging campaign, multiple vehicles driving around the world with tons of sensors, cameras, lidars, scan data, but we basically have the issue that we want to keep doing the same thing, but cheaper. So all the managers are nagging at me to just cut the costs in some way. Do you maybe have any ideas, any new things in your products which could help there?
Yeah. We thought about that. Cost cutting for our products, that's another story, but it's more important for our customers, for you, right? So did you ever thought about compression of video data?
So compressing the camera data, you mean? I mean, we are already compressing everything later on the service.
No. I mean compressing on real time on the system while you log in.
So you mean on the logger, have the GPUs on the logger instead and do the compression there?
Yeah, exactly.
Okay, but I mean, don't I then need to buy more GPUs on the logger itself? So I would have to buy more hardware to save costs?
The opposite is true. So on the one hand, you spare SSDs, right? So you have to pay nowadays, if you're logging raw data, for more SSDs. If you can do the same with compression, you have to invest in one GPU, for example, show you that maybe later on, and you spare SSDs on the other hand. And the best is you also spare upload time so that the log data is instantly available at your engineers, right? They can go on and work with the data.
Okay, so I mean, I can save SSDs, but I mean, how much am I really saving there?
I think so. You can imaginably, think of 10 SSDs maybe for one GPU.
So instead of 10 SSDs, I just have one that I need to pay for?
Yes.
Okay, that is quite something. So, and maybe another idea, could I reuse the GPUs that I have in my servers already?
Yeah, in principle that's possible. However, we ruggedize our GPUs. So we, on the one hand, carefully select them that they meet the requirements that's in vehicle possible to use them without damaging the logger inside, right? So that we can mount them in a ruggedized way. And on the other hand, so we carefully select the GPUs to, let's say, get the most power in one PCIe slot for encoding and compression.
Okay, so what exactly do you mean with ruggedized? I mean, how do you have any example maybe?
Yeah, fair question. So we have a customer that uses GPUs and the AUTERA AutoBox on a racetrack, right? So for autonomous driving on racetracks, and by accident, one of their cars directly ran into the front of a wall and the car is totally damaged. However, no one is hurt. That was the important thing. And also important thing, from a technical perspective, AUTERA is still running.
So the AUTERA and the GPUs are actually still working?
Yeah.
Okay, and our servers don't need to handle that usually. So that's one difference, definitely. But I mean, if I were to build in the GPUs into each logger that I have, I mean, I don't want to take the logger, ship it to you, and wait for a month to come back. So that's that's somehow not feasible.
Maybe, and remember on our I/O cages, we presented the time you bought the loggers from us, right? So you can toolless put them on your desk, right? So remove the I/O cage and toolless open it and put into PCIe cards. In that regard, you can also do the same thing with GPUs and just put it in and put it toolless together again and put it inside the AUTERA AutoBox in the logger. You don't have to ship the entire logger to us, to dSPACE, but you can use it and do it on your own without losing warranty, and it's well documented by our.
Okay, so I can do it myself and documentation is available?
Yes.
Okay, well, you mentioned earlier that I would just need one GPU, but I mean, is one GPU really enough for all of my setup?
So actually we have prepared something and tested so that you can a full autonomous ADAS ID sensor setup be compressed with one GPU.
Just okay. That's a pretty bold claim. Do you know how to back that up?
Sure, I have prepared something for you and will show you that soon.
Can we recreate a complete autonomous vehicle sensor setup with 11 cameras and 8 lidars without stepping into a car to prove the claim? Spoiler, yes, this is exactly what we want to show you together with our powerful logging system. The setup is equipped with 11 cameras, 7 × 8 megapixel, 4 × 3 megapixels, all running at 30 frames per second. We have 8 LiDAR sensors. Other sensors are usually neglected because they have low bandwidth requirement. The AUTERA AutoBox is a rugged, highly customizable in-vehicle data logger. The software is based on a Linux operating system, enhanced with our dSPACE runtime library and RTMaps as end-user interface. This combination lets you focus on data logging while enjoying easy-to-use power of the system. RTMaps in general is a software which is used for both data logging and data replay. It is a highly efficient middleware that lets you quickly and easily set up any multi-sensor application. It already comes with 100 of implemented sensor interfaces, a precise multi-threading and timestamping mechanism that makes sensor fusion easy. At dSPACE, we are also known for our expertise in hardware data replay. We use that knowledge here in our flexible test setup to emulate these 11 cameras and 8 lidars and playback the recorded data with the highest precision in real time. The AUTERA data logger thinks it is in a real vehicle. I will show you the changes that needed to be made. Of course, one should always be careful while making changes to a working system. Let me show you how easy it is to add the compression to an RTMaps data logging application. Here we can see how the RTMaps diagram may look like when doing a pure recording of the camera and LiDAR streams. Now let's add H.264 compression. There are multiple options for compression, but here we rely on GStreamer component, so we add this to the diagram. As you can see, there is a number of data conversion methods already implemented, but we also have the option to use custom data pipeline. The command entered here is executed with hardware acceleration on the NVIDIA GPU that we utilize in AUTERA. After that, we prepare the diagram by removing connections from the raw recording block, detaching the CSI2 conversion output from the color space converter, and disconnecting the sample rate observer. Now the maps image output of the CSI2 conversion block is routed straight into the GStreamer block. From there, compressed data is forwarded both to the sample rate observer for timing and to the recording block for storage. When connecting to a recorder, we can choose the logging format to be used here. In this case, we choose to store the data in MKV container format. Let's finally add a bypass component so that the recorded data is independent from the upper visualization blocks. With this, we are now able to compress and record one camera stream. We can now reuse these blocks to record the 11 cameras that we have in our AV setup. As you can see, a live logging of the whole sensor setup is now happening. The 11 cameras and 8 lidars are right now recorded by our AUTERA AutoBox. Moreover, the GStreamer components are right now doing the H.264 compression of all the camera data.
Instead of the raw camera data, we are recording the visually lossless video data. We are visualizing one of the cameras as it is recorded and one of the lidars. With RTMaps, we can also inspect the stability of the running system at any time, without the loss of any data. As you can see, the camera data is buffered within the memory of the AUTERA, but no overflow occurs. Notice the overall data rate that we have visualized. The whole compressed setup is a few gigabits per second. With that, it takes some time for our 32 terabyte SSD to be filled. Usually it takes about more or less 10 hours for a 32 terabyte SSD until it has to be exchanged in a setup. On our second screen, we can also visualize the live performance. First, on the right terminal, you can see the Ethernet traffic of the incoming Lidar streams. Second, we use NVTop to visualize the GPU utilization. As you can see, the GPU still has plenty of power to spare. Third, we display the output of HTOP, which shows that our multi-core CPU can easily handle all the threads that RTMaps starts in the background.
Now let's check the compressed data after the recording. Compressed video files of all 11 cameras now have only a total size of 9 GB for a roughly 1 minute recording. We then play back one of the recordings to illustrate the current output quality. Please note that the color setting for this footage have not yet been fully calibrated, as this reflects an early stage in bringing up new sensors. Now, after some color space conversion, we gain the RGB videos. We can use RTMaps to synchronously replay all the camera and lidar data. However, its size is only a few % of typical raw data size. So for every developer and tester copying this data, we save time and storage costs. We can even zoom in and out on the 3D data or stitch multiple point clouds together. Now this data can be used for purposes like development, testing and validation.
So Björn, in the demo you've just shown, you were doing the H.264 compression. And I've been wondering, are there other compression methods that I could use?
Yes, we have also H.265 and also HEVC and AV1 with different kind of profiles. Depending on your use case, you can select which one is the proper one for you.
So depending on the project, I can actually adjust the compression that we're doing there.
Yes, exactly.
Okay, and the uncompression needs to happen obviously later on as well. Do I need extra hardware for that?
That's not required. So nowadays you have CPUs with integrated capabilities to decode H.264, for example. So you do not have the necessity to equip each and every desktop you have on your side for the developers with a GPU. You do not have to fear that. So.
Oh, okay. And one other thing I've been wondering, with the demo setup there, with the 11 cameras and such, how much storage are we actually saving?
I've prepared something for you in a slide. So we have the 8 lidars, which 125 megabytes per second, right? We do not compress that in the demo. We also have the 3 megapixel cameras and the 8 megapixel cameras. So 3 megapixel cameras contribute with 540 megabytes per second approximately. And the high resolution 8 megapixel cameras contribute with 3,500 megabytes per second. Each camera runs at 30 frames per second. And that yields or leads us into a compressed data in that setup you show with 105 megabytes per second for the high resolution sensors, 32 megabytes per second with the low resolution sensors, and the lidars are out of the game.
Okay, so instead of this 3.5 gigabyte per second for the 8 megapixel cameras, I only have about 100 megabyte per second. Okay, that's quite a lot actually. So what is the downside of that?
Yeah, we talked already about the CPU side, so you do not have to fear about that. We as you may know, if you want to log raw data, you want to have actually the bitwise reconstructible sensor data, right? So if your use case depends that, you may not choose H.264 compression. So you may wondering, hey, they have a lossless compri. Why is it not possible? So instead of bitwise reconstruction, they mean with the lossless part here that you can visually not distinct between the original image with your eyes from the one which is compressed.
So there's actually a difference between the, let's say, bitwise creating the real data again, so that kind of lossless compression versus this visually lossless that you're talking about now.
Yes, and depending on your use case, you are fine with your current setup, right? So if you do not compress the data like you run nowadays your fleet, you can use that still. But if you want to equip your systems or partly of the systems with a GPU, you can compress it like we showed in the demo.
Okay, so basically to be able to save that much SSDs and that much cost, I should probably talk to my guys in-house, like the guys using the data. For what use case we will be fine for the visually lossless compression, right?
Yes.
Okay, but I mean, saving that much storage sounds like a pretty sweet deal.
I hope so. So looking forward to your answer and the response from you experts at that, and we also eager to learn from you what you think, what's the proper approach from your side.
Thank you, Bernd.
You're welcome. In this video, you see the compression on the AUTERA AutoBox for camera videos and camera data. So you can use the AUTERA AutoBox for compression in your setup, in your fleet. So thank you for watching and have a nice day.
dSPACE, your partner in simulation and validation.